Okay, in our last video, we're going to talk about the shapes of larger molecules. And it's broken down very simply into the idea that we want to work on one central atom at a time. Okay, so if you have a molecule that looks like this one, okay, what we're going to do is we're going to focus on each of the central atoms. So there's a central carbon, a central nitrogen, a central carbon. And we're going to apply the basic ideas for each scenario. Okay, so let's look at this first central carbon. So essentially what we have is a carbon bonded to 3 hydrogens and eventually bonded to a nitrogen. Right, so what we have are 1, 2, 3, 4 regions. No lone pairs, so it is tetrahedral with 109.5 degree bond angles. Right? I'm going to look at the next central atom. So if I focus on what's going on with the nitrogen, what I have is a nitrogen double bonded eventually to a carbon, singly bonded to another carbon, and has 2 lone pairs. So I have 1, 2, 3 areas of electrons, one lone pair means that my shape there is bent, slightly less than 120. Okay, because 3 regions means that it's trigonal pyramid. With 1 lone pair, I get a bent molecule with slightly less than 120 degree bond angles. Now if we look at our third central atom, our other carbon, I have a carbon double bonded to a nitrogen and double bonded to an oxygen. So I have 1, 2 regions of electrons. No lone pairs, so it's linear with 180 degree bond angles. Okay, so you can piece out larger molecules and determine the shapes around each central atom that you have. Now our last topic is about the terminology that we use to talk about different versions of the same molecule. Right, so if I have one that looks like this, my formula will be C2H2Cl2. Okay, but I could just as easily draw this molecule in several different ways. Okay, or, whoops. Okay, all of those have the same formula, C2H2Cl2. So what we do is we assign terms to describe the orientation of the various parts of this molecule. One is cis, and that means same. Okay, the other is trans, which means different. Okay, so if I take, and I'm going to look at this top left molecule, and if I bisect that molecule along the double bond, if I look on the two sides, those two are different on the top and the bottom. On the top, the chlorine's on the right. On the bottom, the chlorine's on the left. Those things are different. So this would be a trans configuration. Let's look at the top right molecule here. If I bisect that double bond, on the top I have two chlorines that are the same, and on the bottom I have two hydrogens that are the same. That is a cis molecule. Okay, I have chlorines on that are matching, hydrogens that are matching. In fact, if I were to bisect top to bottom, I have chlorine on top, hydrogen on bottom, chlorine on top, hydrogen on bottom. Everything's the same. No matter how I slice it, horizontally or vertically, they are the same on both sides. Okay? So our bottom molecule here, if I bisect it this way or this way, we have a cis molecule. Right? It's easiest to see with this one if I bisect vertically that I have exactly the same two hydrogens on the left, two chlorines on the right, the same. Top and bottom are mirror images of each other. Okay, so cis versus trans is mostly concerned with orientation. Okay, so with our top left version, trans, top I have hydrogen on left, chlorine on right. Bottom I have chlorine on left, hydrogen on the right. Okay, so that's where they are different. All right, and that does it for our Chapter 10 videos. Hope they've been helpful. I'm hopeful that your experiences with the lecture, the Zoom lectures, have been more helpful, and these videos actually end up being supplementary. But either way, have a good time.